Okay, welcome back, and I hope you are enjoying the lectures and you are finding this important and very kind of good for your understanding. I think I have tried to give you the concepts for undergraduate as well as postgraduate, and then in between I have been discussing about the research topics as well. So I think it will be kind of in a very good lecture series, and if you study whatever level you are actually, so you can accordingly decide that whether you are for the graduation level or PG level or kind of PhD levels, or you want to do some research on this one. And if you are a non-academicians, you are attending for example as a consultant, this also will be very important. So welcome again, and in this lecture we are going to discuss something very important like aerosol deposition mechanism and factors influencing deposition. As we know that aerosols are very tiny particles that are suspended in the atmospheres, and their consent, neither we can see them nor they are actually kind of what you call deposition can be actually seen or visually, but we cannot see actually whether they are deposited on the surface. But if you remember, if you have a very clean room in your office or in your home, if you just close it for few days and you go on a vacation, you come back and you see lots of dust will be there on the table, chair and other things. So lots of aerosols will be deposited, and how these things are coming. Remember that you have already closed your rooms, there is no space, so there is nothing, or there is a very little chance that something can come from outside. So this becomes very important. But still you will see these pollutants that are deposited. That is one signature. Then you also see lots of aerosols that are deposited on the monuments. Okay, and there were studies that indicated that in the the decoloration of the Taj Mahal that happens was because of the excess deposition of kind of acidic species that are there in the atmosphere. We also see this important deposition of these aerosols and then acidic species during, especially in the plants, or especially when the farmers are doing their kind of growth, when they are growing some kind of specific kind of for example potato, peas, they are very severely affected, and because their leaves are very kind of soft, and the small deposition can affect their their kind of growth, so photosynthesis actually. So this becomes very important over the ocean also, this becomes very important. So let's see that how we are discussing. So there are actually two ways that aerosols can be deposited. One is actually called dry deposition, and as the name says, dry means there is nothing, no water vapor or anything that is there in this one, or no water there, and this is deposited directly onto the surface by the gravity or turbulence. So this is very important, and this is also very important because dust transport, for example, when the dust transport happens, this dust can be transported over the oceanic regions and they can be deposited on the kind of different water bodies. And because these dust particles contains lots of pollutants, we will discuss in this one that what are the important key nutrients. I am not going to much details, I think I have already discussed this one, but yeah, when they are transported, they can be deposited and they can affect the biogeochemical processes. And if you have a smaller particles, they will be moving primarily through Brownian motion, whereas the heavier particles will settle down due to gravity. So this is very important. Okay. And we will see that what are the equations that we can use. The wet deposition, this is also known as wet scavenging, is a process by which the atmospheric aerosols fall to the ground through precipitation. So there is a very important, whether it could be a rain or snow. So pollutants that are there in the atmosphere, when the rain falls or the snowfall happens, these will be actually attached, these aerosols will be attached, then they will be deposited. So this is actually like kind of very important. Yeah, so I am not going to much discuss here. this is, you have like this kind of aerosols, and they are depositing by their own because of their gravity. They are nothing actually that is there for them to deposit. And then here you have actually CCN, cloud condensation nuclei, and this in cloud, that is actually this actually when the cloud is there, this cloud can lead when this rainfall happens. Whatever the aerosols are there in the down, they will be actually kind of scavenged. Scavenged itself is a meaning, means scavenged because of the some external agents like rain or snow. So with that they are deposited. And if you remember, what are the regional and global impacts? We have in the oceanic regions, we have high nutrients and low chlorophyll regions, which is called HNLC. Okay, so HNLC means there are high nutrients but chlorophyll is low. This means even there is a huge nutrients are present, but the productivity is low. So low chlorophyll means low productivity. So deposition, for example, deposition of iron and nitrogen, this can significantly enhance the productivity. So this, for example, in these regions there are other nutrients that are already present, but they are actually like limited by nitrogen and iron, and nitrogen and iron are key nutrients that are needed. So because of their less presence or the concentration is less, these regions will not see high productivity, and the productivity will be very low. So if you do kind of somewhere from, if we can supply iron and deposit in that one, then there can be actually iron fertilization. Okay, for example, through the dusty storm I was talking about, especially for example in the Southern Ocean, there was actually like experiments that were conducted in some of the HNLC regions, where that iron was actually spray over the ocean, and they found that when they spray the iron, the productivity was increased. Then you have a kind of oligotrophic regions. Here actually this is limited by phosphorus and nitrogen. So because of the lack of phosphorus and nitrogen, the productivity is low, and if they are deposited, they can boost the phytoplankton growth. So oligotrophic regions, and this is very important region is actually like Atlantic Sea. And this happens, for example, due to the biomass burning. Biomass provides an important source of phosphorus and nitrogen. So when these are actually deposited, they can actually lead to they can boost the phytoplankton growth. Then over the coastal regions, excessive nitrogen deposition. Okay, this is also very important. So if you have huge excess deposition of the nutrients, what will happen? The nutrient will not be consumed by the phytoplanktons or the living organisms that are there, and this can cause kind of situation like eutrophication, algal blooms, and then hypoxia. So this is kind of things are also very important, and one of the very important example is that Gulf of the Mexico is known as a dead zone. So you don't see much of the kind of things that are there actually, activities. So excess, as in the lecture that we were discussing about the toxicity, excess deposition or excess dose, here if I put in that term, the excess deposition or excess dose of nutrients can also lead to less productivity. And important is that because of their importance over Asia and over, for example, in Asia we have a Asian acid deposition monitoring network. In East Asia, this is called EANet. So East Asia Network of Acid Deposition Monitoring. So this an Asian is specific, an Asian perspectives, and USA has their own actually national atmospheric deposition programs. Lots of activities happening in the because on the wet deposition and dry deposition, and the important is that is actually knowing the annual and seasonal wet deposition fluxes rates are very important in understanding the biogeochemical processes. if we want to study some of the biogeochemical processes, we must understand their annual and seasonal deposition of, for example, species like calcium, magnesium, nitrate, ammonium, sulfate. These are the ionic forms, and most of these are actually will be deposited via the aerosols. Okay, so this is very important. And then of course inorganic nitrogens. Okay, like then you have annual and seasonal mean concentrations of, so this is actually dry deposition. If you have actually like mean concentration in milligram per liter, means you can calculate in the wet deposition also. So if there are actually studies the measure actually wet deposition usually is high compared to the dry deposition, and because of this one, wet deposition monitoring is more compared to the dry deposition. Another also the dry deposition needs lots of other activities, because it is actually conditions, atmospheric conditions are actually what kind of conditions are there. So that is also there. Yeah, this is I discussed. So for example, impact of nutrient deposition on the biogeochemistry. So iron is actually very important, and especially the it simulates the primary production. So is a limited nutrients in, especially in the HNLC regions I discussed over the southern ocean. Okay, and its deposition can enhance the phytoplankton growth. And if you have more phytoplankton growth, this means you can have more of carbon sequestration. So enhanced primary production can increase the biological pumps where carbon is sequestrated in the deep ocean. So in terms of climate, this is also very important, because this iron deposition can lead to the kind of carbon sequestration. Then when it comes to the phosphorus, you have phosphorus is also very important, and this promotes productivity in the oligotropic, especially in the nutrient poor regions, and this influences the composition of phytoplankton communities as well. So what kind of communities will be there? Usually this and the oligotropic regions, as I discussed in the previous one. Again, in the nitrogen is actually limiting primary productivity in the nitrogen limited regions, and if you have excess nitrogen, so it can cause eutrophication. So this is also very important, and in India, especially in Ganges we see eutrophication, and even in some ponds you will see, especially when just after the first rain, and then sun becomes very kind of bright, and photochemical activity becomes very important, and photosynthesis starts very fast in that case, because that was the before the rain it was actually nutrient limited, and when the rain happens, this rain brought lots of aerosols, because there was no rain earlier, so lots of pollutants were there in the atmosphere that also get deposited, and if the rain can also transport some of the nutrients through surface transport. So surface transport of runoff processes, it can also bring lots of nutrients, and in that conditions eutrophications becomes very important. Yeah, so the same things I discussed, dry and wet depositions. Now especially the nitrogen nutrients, this supports about, for example, nitrate nutrients through the atmosphere supports about 20% new production in the summers, and this new production of the phytoplanktons. So this means you have more photosynthesis. When you have more photosynthesis, more particulate organic matter will be actually produced, and this will be kind of food source for some of the species, and microbial respiration. This will actually dissolve oxygen consumptions, and then you have kind of summer deoxygenation. So again, lots of processes, inbuilt processes are the kind of mechanisms that will be there actually. The deposition, there will be a feedback mechanisms. So I am not going to discuss in the much of the feedback mechanisms. And there is another very important thing, that if you have more acid deposition, and we know this ocean deposition can affect the pH of the water. So and we know that through lots of studies that there is actually process of ocean acidification. This ocean acidification means the pH is actually decreasing, and then pH is decreasing. Ocean acidification means kind of acidic ocean. Okay. and this means pH is decreasing, and when pH is decreasing, you have more of H plus ions, and then if you have kind of acidic conditions, and you have actually bases, for example coral reefs, okay, which are actually nothing but calcium carbonate cells. This can actually react and they can destroy, this can be actually damaged. So this is very important. Not only that, some of them because these are actually when they are happening, this for example okay, yeah, so in the late 1900 or 1800, less produced acidity, lower concentration was there in the lower concentration of CO2 was there in the atmosphere. So the carbonic acid formation and then free hydrogen was less actually, and then we had a kind of abundant healthy corals, mollusks and other marine calcifers that were there in the atmosphere, and somewhere around say in 2100 it is projected this will increase the acidity. Here if you see the pH was about say 8.1 to 8.2, here the pH reduced below this one, so somewhere actually 7.8 or 7.9, so the pH reduced, and pH reduced becomes more kind of acidic one, okay. So although acidic means here it is not, because the pH is always more than 7 here, but here we are talking in the terms of the acidity, okay, or the H plus ions, so it will be more acidic, and then you will have a more acidic, so you have more carbonic acid formation, you have more free hydrogen that will be generated, and at the same time you have a fewer carbonate ions, and when you have fewer carbonate ions, because of this one the sum of the carbonic acid carbonates ion will be less, and then you have fewer or smaller marine calcifers. So the calcifers they may probably either not grow, or whatever they are grown they can be actually decalcified, or their skeleton can be damaged. So that is very important. But here also it is one of the very important thing that actually ocean X has its own buffering capacity. So this means the deposition of a strong acid consumes alkalinity, further reduces the ocean's capacity to neutralize the acid inputs. This is also very important that we have to study. And then this impact on the marine life I have been discussing, like for example, so acidifications can affect calcifying organisms such as corals and shellfish, disrupting, and they can disrupt the marine ecosystem. Similarly, yeah, so I think I have discussed this one, acidification impact on the corals. This acidification will reduce the calcium carbonate saturation, and this impairing the formation of cells and skeleton. So because you have more acid, so the calcium carbonate saturation will not be there, so you will not be having a formation of cells and skeletons. Phytoplankton's community nutrient enrichment may favor certain species, potentially disturbing a kind of ecological balance. So phytoplankton, because of this one, the phytoplanktons will again accordingly adjust, and some of the phytoplanktons because of the nutrient enrichment can be actually favored, some might be actually disrupted, okay. And then it can also change the food web that is there in the ocean itself. So ocean acidification, weaker coral skeletons we will have, and then if you have kind of in the future what is going to happen, reduced growth and calcification. So this will be a very big problem, that ocean will be affected. And these are the key. Not only that, I discussed about the nutrient also, but there is actually some of the things like organic carbon also. This is actually directly they can be transmuted, and this is actually the particulate organic carbon flux that is there over the sea water due to deposition. And particulate organic carbon, for example, is about 1.54, and dissolved organic carbon flux is actually like 1.22 gram carbon per meter square per second. So this kind of and this is per annum, per annum, A means here annum, per year. And then they can actually lots of what will happen, and then nutrients deposition, indirect organic inputs. This can boost phytoplankton growth through photosynthesis. This can, by increasing the photosynthesis, and you can have a new production, and then which will kind of going to again affect the marine ecosystems. The way it is calculated, the dry deposition calculation is very simple. FD is nothing but actually VD into C. Here VD is actually deposition velocity, and usually this is given in meter per second. Okay, and concentration, as we know, we are talking about the atmosphere, so the concentration will be actually microgram per cubic meter. So in a way this will be having unit like microgram per meter square per second, and but this is actually like the unit that is you can calculate, but they are generally reported microgram per hectare per year. So you can calculate, and per meter square you can report, or per hectare you can report, because in the larger area these numbers will be very small. So when these numbers are reported, they usually are reported for larger area. So you take a hectare of this one. Yeah, so this is again the dry deposition is usually represented as meter per second or centimeter per second, and concentration is again in the meter cube per microgram per cubic meter. And as we know, dry deposition flux is highly dependent on the VD, and so this means any change or deposition flux can be affected if there is a change in deposition velocity VD. So for example, if there is surface roughness or turbulence near the surface, or you have a particles or gas properties such as size and reactivity. So these are the processes that can affect your kind of dry deposition. Just a small question, it's very simple question, that suppose a pollutant concentration is 1.5 microgram per meter cube and deposition velocity is 0.1 meter per second. Can you calculate VD? Yes, you can calculate FD. FD will be 0.01 meter per second, and 1.5 into 10 to the power minus 6, it is microgram. So you have like 1.5 into 10 to the power minus 8 gram per meter square per second. So this is actually like sometimes you will also see that units are reported in gram per meter square per second. So just be careful in the objective questions. Sometimes the unit is given microgram or gram per hectare per annum. Sometimes it may be given as milligram per meter square per second, or sometimes in gram per meter square per second. So don't be confused with this one. This is very important. On the other hand, if you have to calculate bed deposition flux, so bed deposition flux means the concentration are actually in milligram per liter, because they are in the aqueous solution phase. So you have milligram per liter. So you have a concentration of species that is actually milligram per liter, and you somehow measure the precipitation, that how much actually precipitation happens actually in liters or per milliliters. And then when we are actually collecting this one, we know we usually collect like this kind of things will be there, and then somewhere you have collector. So this is actually a kind of circular. I'm sorry, I'm not very good in drawing. So if you need the radius of this one, so you have area, how much area, assume pi r square. So based on that, this area will be receiving the rainfall, and if you know this area, you can calculate that how much actually the area. For example, here 0.00314 meter square is taken for a specific collector that is given, and then so you have a area from here, and you have to just use kind of 10 to the power 6. So again you can calculate kind of bed deposition flux here, and this is usually given again kilogram per hectare per year. There is actually wash out or scavenging ratio coefficient, that is 1/s, it is given 1 per second, and then you have airborne concentration, that is of course is given in the meter cube per second. So the scavenging coefficient, like here scavenging coefficient, note that it is in unit is actually per second. Okay, so this depends on the precipitation intensity, particle size, solubility of the gas or particulate matter that is there in the atmosphere. So this is actually very important. We can calculate the dry deposition and we can calculate the wet deposition, and when you see Ft will be given as F dry plus F wet. So from that you can calculate the total deposition. And when you have total deposition, you can calculate what kind of ecological impacts that can have and the ecological impacts that particular nutrients can have via deposition. So yeah, I think I have covered sufficiently about wet and dry deposition. I suggest here that you should be studying more, especially for the research students, that what are the factors that are affecting the precipitation, and then the factors that are affecting the, for example, VD, dry deposition. So those things has to be considered. Lots of research has been done. Lots of research activities are still going on this one, and we although we have some kind of quality data, we still needs lots of data on dry and wet deposition. So if you are a researcher and doing research on the aerosols or kind of precipitation chemistry, you can do lots of research on this one, on the dry and wet deposition of the nutrients. So yeah, I will stop here, and thank you for your patience listening.